Hi, I've been asked about some of the problems on the final review sheet, so I made this video to explain how I got my answers to some of these problems. First of all, number 9, if -4, 9 are the coordinates of a point on the terminal side of angle theta. So here is the point -4, 9. If that's on the terminal side of an angle, here's that angle in standard position. So here's the line from the origin out towards that point, -4, 9. The exact value of the sine of that angle would be y over r. The y coordinate is 9, and r is the distance from the origin to that point. So that would be the square root of 16 plus 81. -4 squared plus 9 squared is 16 plus 81, so that's 97. So when you take y over r, that would be 9 over the square root of 97. You could also rationalize the denominator and write it as 9 times the square root of 97 over 97. So if that's the sine of theta, then theta itself would be, well, let's see. If the sine of theta is 9 over the square root of 97, you'd expect theta to be maybe the arc sine of that. So I get my calculator, and right now it's in radians mode. So if I want the answer in radians, I'll just leave it like that. If I wanted it in degrees, I could change to degree mode. And if I ask for the arc sine or inverse sine of the number 9 divided by the square root of 97, the calculator tells me that that is 1.15 something. But that's not the final answer. That's not the angle I'm looking for, because that is an angle in quadrant 1 that has a y coordinate of 9 and a distance from the origin of the square root of 97. Remember, arc sine always gives you an angle that's somewhere between -pi/2 and +pi/2, or somewhere between -90 degrees and +90 degrees if you're in degrees. But it gives you an angle somewhere in quadrants 4 or 1. But the angle that we're dealing with here, hopefully you can see, that is in quadrant 2. So to go from the angle we got in quadrant 1 to the angle we really want in quadrant 2, here I'm going to have to subtract from pi, or 180 degrees. So if I take pi minus the number we just got, then I get the angle that we really want, which is about 1.989. If I had done all of this in degree mode, then the inverse sine of 9 over the square root of 97 is about 66 degrees, or about 66.04 degrees if you want to be a little more precise. That's the angle in quadrant 1, but if I take 180 minus that, I get about 113.96 degrees, which is the angle we actually want in quadrant 2. Number 14. Fill in the blanks. 10 cosine squared of 4 theta minus 5 equals blank times the cosine of blank. So we're dealing with the expression 10 times cosine squared of 4 theta minus 5. And can you think of something that fits that pattern in one of the identities that we've worked with? It's one of the double angle formulas, and I will give these to you on the exam. So you don't have to have these memorized, although if you do, that's great. But you have to remember to look for something like this. So do you see one of these identities, one of these formulas that kind of matches what we've got going on here? Yeah, 2 cosine squared of u minus 1 is kind of like what we have going on here. In the place of u, we have the expression 4 theta. And we don't just have the numbers 2 and 1, we have the numbers 10 and 5. But we could factor out the common factor of 5 so that it's 5 times 2 cosine squared of 4 theta minus 1. And then the part inside the parentheses after we factor out the 5 really does look like this. So we've got 5 times something that is equal to cosine of 2u, where the part of u is being played by 4 theta. So we've got 5 times the cosine of, remember I said u was 4 theta, so 2u would be 8 theta. So that's what goes in the blanks. 10 or 5 times the quantity, 2 cosine squared of 4 theta minus 1 is equal to that 5 times the cosine of 8 theta. The cosine of 8 theta, that is the cosine of 2 times 4 theta, would be equal to 2 times the cosine squared of 4 theta minus 1. And then we just multiplied that through by 5. What about number 15? If the tangent of 24 degrees equals 2 times the tangent of x over 1 minus tangent squared of x, what's x? Again, does this fit any of the patterns from any of those double angle formulas? Yeah, it's this one. So the x is in the position of just u, and the 24 degrees is in the position of 2u. So if 2u is 24 degrees, what's u? 2 is 24 degrees, so u would be 12 degrees, and that's what x is. So what's x? It's 12 degrees. And I was asked about number 18. Write the complex number 10 times cosine of 99 degrees plus I times the sine of 99 degrees in standard form. Well, if I just get my calculator, and since this is 99 degrees, make sure I'm in degrees mode. Now I could just put this whole thing in like this. 10 times the cosine of 99, and I'm in degree mode, plus I times the sine of 99. Whoops. So that does show up as negative 1.56, and then some more digits after that, plus 9.987 something times I. So it looks like I made a mistake. Probably I forgot to multiply that part by the 10. So that shouldn't be 0.99, it should be more like 9.9. So if you take 10 times the sine of 99 degrees, you do get approximately 9.9. If you forgot to multiply by 10 and just put the sine of 99 degrees, you get about 0.99, and I think that's what I must have done. So I'm going to go back and fix that. And there, that's what the answer should be. Sorry for any confusion. If there are any of the other review problems that you have questions on, you think I might have made a mistake on, or you want to see how I got them, go ahead and ask.